Hello and welcome back to another session of Google.rs development. It's Byron speaking, and it's issue 122. It's a big one, and it's really just a catch-all for the work that will be required to get concurrent builds to work right. Long story short, in in basically the nightly cargo, you can configure the target directory, which means that from now on, where am I? I'm in the wrong spot. That from now on, you can put everything into one target directory. This basically means that all the dependencies shared among the projects, which is a major amount of time spent for each project, can be shared in one directory, which is totally awesome. So for instance, okay, I've built YouTube here apparently, but I could also build Discovery, make Discovery 1, CLI cargo, arcs is built. So it should probably be relatively fast here to get a debug build out of this, just because all the dependencies are already present here. The problem with that is that it actually works worse than it worked before because of the concurrency issues that happen if there are multiple cargoes operating on the same files in the same target directory with the same, algorithm. Right now, it can happen that things just get overwritten or changed while another cargo is working on it, and this just shouldn't happen. And to make this work, and there's Discovery, as you can see, this is how that works. So to make this work, one would have to teach some sort of locking mechanism to cargo, and the good thing is we can implement collaborative locking. This means that the application that we talk about will behave correctly based on whether or not a lock is present. And I have discovered a nice library here, a nice great file lock, which kind of shows how it can be done. It has undergone heavy modifications in the past days, and it will see even more modification just because I have no idea what we really need. For now, it only works for Unix, Linux, OS X, basically everything that is not Windows. And once we have some working example of cargo, it will be ported over to work on Windows as well, which hopefully will then be what cargo needs to compile on all the targets that it knows, which is everything that Rust supports, right? And there's not much to it. It's really mainly documentation. It's really, really simple. It calls into some C code here, which was a new thing for me to do. I mean, not that it would ever be hard or something. It's just that I've never done it, but it's good to finally have done that. And there's so much more to learn about Rust in general, especially when it comes to unsafe code or calling into C, which, as you can see, is highly unsafe. Okay. So, let's actually just test it, because I have switched. Actually, did I switch? I think I updated cargo Rust stable to 1.1, but this one needs nightly for the test, so nothing changed here, I suppose. No. Good. So we are at a stage where I will just add whatever I need when I try to integrate this into cargo to the file lock crate. And right now there's a simple lock and unlock. We can determine if it's supposed to be blocking or non-blocking and which access mode we want to lock. So this is single writer, multiple readers kind of locking. That is also basically what Rust does when borrow checking, right? It's the same idea. And I think for now there's not much more to be done here. I've recently added the remover struct, which does nothing more but to drop or remove a file when it's dropped, which is now something I could use in cargo. So I've prepared something already and kind of realized that we will have this pattern a lot. So sometimes, actually probably just in one case, we will have a fingerprint file that already exists and that we want to keep, that we can lock, or in all or many of the other cases, we do not have a file, but instead we have to possibly create a log file ourselves. And these semantics are something we want to bake into a type now. This auto removal type is something we can use to accomplish this. But yeah, as I said, I have no real idea. So here we have the log file path. It's a path buff, so it can be modified. This is something we will have most of the time. And I think we'll just pass ownership. What I'm thinking about is to have a custom cargo log file implementation that allows us to create one, an exclusive log. Let's have an exclusive log file. It doesn't really matter what we write to it. And it also, it's pretty much what this thing does. It should just remove itself automatically. And in case it does exist already, we do not care about it. It's just that the lock will take care of everything, locking itself. Yeah, I think that could be good. If we fail to obtain a lock, basically also we will only try to remove that file if it's our own one. So that's also quite important. Yeah. And it must be able to deal with cargo result. And here it's going to be interesting, because this thing has to convert itself to all the different results that there could be. And good. Oh wait, cargo result returns A. Let's have a look at errors. It was actually quite complex, this error setup, but also very, very powerful. Sometimes it goes through several conversions, which are automatically selected to get the right type. So yeah, what's a cargo result? Cargo result is a box cargo error. Okay, this is basically what we want to have. We want to have our own cargo error. Maybe not our own one, but some cargo error. And yeah, let's see what there is. Do we need our own? Yeah, I just want to have one kind of error that I can actually use. So we have a process error, which probably is for executing processes, and a concrete cargo error. This is something I can use, I think. Can I? It has private fields even. So does it? Yeah. I don't know who instantiates this. Yeah, how do I do any of this, damn it? Oh yeah, so that's how it works. So you call these things internal error, internal human, and then you pass in some displayable thing which shall represent your error. Yeah, I think that's how this could work. And then you can work with try. So I think the semantics I'd see here let's try to write it down. We have a log file path, and we have an exclusive log. Something like that, which gets the log file path. And then we just try to lock it. And this log, wait a moment, this log we have to get here. And we try on it, log acquire. And I wonder, let's say how the API looks like. I think I looked this up once before, but didn't get anything conclusive here. I don't think acquire is used in a lock. How is it used? What do we have here? We have wait. Okay, that's a condition though, so it's more about mutex maybe. So here it's called lock and try lock. So we could have the same, and lock will block. The thing is, I don't want to call lock, right? Try acquire. Is there any better thing any better name that we could use? Lock read. Actually, there's something we can do. We can have a similar interface to an RW lock, which is exactly what we have. However, when we create this file, we could also delay the creation. Now that I'm thinking about it, we could delay the creation. Yeah. Why not? This way, we can say write and try write, which is similar to the RW lock interface, which is kind of what I'd want here. Yeah, exactly, huh? And write will, yeah, and lock result. Poison error. How can there be a poison error? The poison error is can probably especially happen with try lock, huh? And it's kind of, or with try read or try write. This is mainly what we see here. And usually it wouldn't happen for write, because that will usually just return when it's ready. Blocking the current thread until it can be acquired. Yeah. Okay, I think that's the kind of interface I would want to mimic. There's no trait for this, so nothing to worry about there. Good. And yeah, this basically means that we create or we try to access the file only when we do the locking. You don't do it right away. Okay, cool. Makes sense, because that's when we know what to do. Okay, so I want to have a write lock which is exclusive, which is the important part here, right? And yeah, I think, yeah, okay, I think I kind of get it now. Try read, try write. So for the cargo version, I just want to have, I think I would call this, because this exclusivity is based on whether you want to read or write. So file log, it's a file log, right? And the cargo version should just have one implementation for it, which has like write or read. And then we have the ability to use the configuration that we want to also take here for the cargo version of it to determine whether you want to be blocking or non-blocking, because the whole idea is to be able to configure whether cargo should abort in such a case or just wait. And yeah, because it's all based on the file system and logs, I think it's also safe to do it without the possibility for deadlocks, even though these could, of course, happen under circumstances, I guess, but shouldn't. Yeah, I don't know. We'll see. Default will be to fail anyway, so that should be fine. Yeah, I think I got the idea now. So we can go back to file log and provide that interface. So we have a log type here, and I think I also, yeah, maybe I can clean up a bit. So access mode, log kind, log. And here's some external definition declarations. All right, good. So what else do we need? What about a file log? Derive, debug, please. Equality we can implement, and partial equality we can implement as well. Pub struct file log. And this shall be a type creating a log file on demand, which also removes it. Yeah, it supports multiple reader, single writer semantics, and encodes whether read or write access is required in an interface similar to the one of the RW lock. Is it called like that? RW lock, yes. Okay, let's just link it. Link up the standard version. It will remove the log file. So yeah, when we'll remove the log file, if it couldn't acquire the log, I think it will not try to remove anything, because then this would mean that it didn't actually create the file. If it could acquire the log, it will create it. I think this is how we should do it. It will delete it. So log file, it possibly created in case a log could be obtained. So this is kind of a racy situation, because multiple log files, well, could possibly exist and try to remove the same file, but we will not. Yeah, we have an implementation that will just work properly, I think. Well, so we will handle this with an optional remover that takes a path buff and does things. Okay, so because to build a path, you usually need a path buff. And how do we do it down here? I think we have a borrow, right? Borrow path buff. And I wonder if we can, yeah. I tried to work with path. This kind of was difficult because it's unsized and stuff. And yeah, it really doesn't want to be part of a type. So using path buffs for this seems to be simpler, but I'm not sure if it's a very rusty way to do it. Anyway, we will have. Why is there just 2 spaces here? Excuse me. Like that. Much better. So, well, we have a. We will keep a path and we will have a file that we keep, well, the file we keep open so that our log kind of makes sense. And once we are removing ourselves, we wanna close, yeah. How does it work here, by the way? Because this thing shouldn't try to remove the file if it's still open. So now the order of operation is important, I think. So the file here, oh no, wait, that's the wrong one. Here, that's our temp file that we use in many cases. And it has the file, which is open, and a remover. And on drop, the file will be dropped and the remover will be dropped as well. And I'm not sure if it's now based on order. So what's the the drop order of struct members? Rust drop order. When a type is no drop impl, its field appears to be destructed in order of declaration. When a type does have a drop impl, that order is apparently reversed. That's very surprising. So in order of declaration, 1, 2, 3. So it's three, two, one. Okay, so actually these would have to be inverted, huh? So that the file gets dropped first. Drop me no impl. Okay, so is this fixed? And what's the final order? That's very important. So here probably you see what the final order will be. Its fields should still drop in declaration order, just as they do when the struct does not. Okay, declaration order, right? So this one is dropped first, and then this one. Okay, and this is very important, because in Windows, depending on how the file is opened, this removal wouldn't work. Even though when you open something with Rust, it's a bit different. It follows the Unix semantics, so that's pretty cool. However, we can try to make it to do it right. So by accident, I think we have been right here. So inner goes first, then goes remover. All right, good. So it's kind of very similar. We have, I want to keep that file because it has to remain open. So that's an optional file. I might not have any of this. Yep, an optional file. And then we have a remover that works in our path buff, which we will also keep around. I think we will just take ownership of it. People can clone it. And this is something we will need. This is what we get initialized with. That's clear. Okay. So that's our path buff. Did I bring it in? I did. And then, yeah, we could implement this ourselves. We could also use the remover. The remover will take a reference to our path buff. I kind of feel silly to implement this using a remover. I would like to just implement drop myself here, because the complexity added through using a remover is higher than the gain, I think. So we got rid of all the generic type parameters, or the type parameters. That's very nice. So drop, remove self path. There's no need to borrow stuff, but we will do this. And we don't care about the result. So that should be a valid drop implementation, provided that I implement it for file lock. That is that. Cool. Oops, it doesn't like file. Why does it not like file? Let's try to build it. Okay, so it doesn't support equality and partial equality. Support for clone probably isn't there either, which should be fine. I will try it though. Maybe it is. Nope, it's not, because file can't support clone. Even though it can duplicate file descriptors, it's probably just not implemented that way. Maybe it's a separate thing. I don't know. Also, doesn't matter. So impl file log. What do we have? We have new, because new doesn't create the file just yet. Only when we attempt to lock something, it will create the file. So fn new, which takes a path to the file, and it will take ownership of it, returning a file lock. And that's a path. File is none. There we go. Oh yeah, and we probably also want to keep the lock, huh? Which, yeah, we can, I mean, let's see. It's kind of, you know, we can kind of just use this one as well, because that's just a pure, yeah, based on the file descriptor. Probably you want to use this because this will at some point be platform independent, and then the types change and stuff, and I guess we do ourselves a favor by keeping a lock type that will store the file descriptor, which it just needs to store to support drop, unlock on drop, which is implemented here. Let's put it down here so that's a bit closer to where it belongs. All right. And I'm thinking also to restructure. So once we have implemented that guy, I think we want to split it up into multiple files and then just use lib to pull in what needs to be pulled in to define the interface, basically, because that's kind of difficult to read here. Yeah. Actually, it's something we should probably do first, should we? That should still work. Yeah. Yeah, let's do it. Let's refactor this. Let's factor this out into a separate file, into multiple ones. So lib will provide the public interface. And then we have a lock implementation, Google.rs. Which will contain this stuff. Let's put the file lock stuff up here for now. So it's basically all of that. Access mode, drop lock. Yeah. So the remover, it can be doubted that we actually need this, but we will see. So here's Google.rs. There you go. So I guess I start out with just copying everything here. And then we pull it in, mod lock. And then we define what we want to provide here, which is the lock, then lock kind, lock mode, access mode, that is called. Then what else? Yeah, that's pretty much it. It's good. Seems to be that. And this raw FD thing. Yeah, we will see about the warnings that we will get. Then what else is there? There's a represents a write log on a file. I think I managed to not copy the entire documentation. Good, so now we have a file log, which I might just put into its own distinct tests, process log, support, unit log. So that's the test for log. We might have a different test suite for the file logs then. Yeah, so that's structured that way. And the remover, I still don't know where to put it. I would put it into util because it's really just that. Just a tiny file then, but who cares, right? It's about the structure. Oh, so now we are missing, I think, only path and fs remove file. Like this. Good, so he should be happy now. We also pull it in. Mod mod util. Now we re-export pub use util remover, and that is that. Cool. And now file log. I think I will just call it file log, mod file log, pub use file log. Yeah, I think it will only be this one type, so let's not get ahead of ourselves here. And this stuff I will just get rid of. Voila. That's the log. And I don't have a file log yet. Here we go. Voila. And here we just need pub use std. Pub use. We could do that, I think, but it makes not much sense in our case. Path buff. And an optional file. Use stdfs file. And what else? Remove file. Remove file. There we go. Okay, cool. So that exists. I don't really expect the test to work just yet. Ah yeah, util borrow. Use std borrow. And that is that. Cool. So log path buff remove file. Cool, it's even highlighted for us. Look at that. Beautiful. What else? Error. We forgot to export the error type. And there is something, okay, news never used. Is there anything else? Unused imports? No, I think we are good. So that's the refactor. Ah, damn it. Can't stage this. I hope this would at some point be fixed, but I kind of gave up hope on this one. So it's not shown correctly, but it's actually already there. It's fine. Let's prepare the commit. Now it's shown correctly. Weird. That was a bug. Refactor. Lock. Removed. Oh wait. Moved implementation to various files. That way we keep our we improve structure and make the code easier to maintain. Well, improve overall structure and make additions more easy. Yeah, I think I can live with that. Also, yeah, we started implementing the file log. Which is a convenience wrapper around the existing log functionality. There we go. Cool. And yeah, it's 35 minutes in. I think I call this a session. We shall continue in the next session with implementing the file log interface and writing tests for it so that we can then use it in Cargo, which also receives yet another version of it. So thanks for watching and have a good day.